So just we observe the 4 steps of collecting data, processing data, doing few analytics on the given data, and then taking decision making, right? So we did on electrical data, right? So in electrical data, voltage and current we can sense and we can take. So just like your electrical experiments, so you can record the voltage using the voltmeter, that is the sensor, that is the measuring device, and we can record the current using ammeter, and we have to take the information of voltage and current, and we have to calculate the electrical power. So that is what the processing, and based on that we have to identify the average power, and when there is a change in power, uh, you, means considerable change in power, then something is happened in the system. So based on that we can decide. So this is what an electrical example. So I think no one is from electrical branch, right? Anybody? No. So let me take another example, that is mechanical. Even in case of mechanical also, so if you have rotating devices, there you can identify the faults in rotating devices, and you can find out the uh, uh, means abnormal actions in the vibrations, etc., etc. So again, in such example, so again the process is, again you have to collect the information with the help of sensors from the device or from the system. We have system, mechanical system, where you have to identify the where you have to collect the data. So the data collection will be the primary step. But whatever the data we will take with the help of sensors, we will record with the help of measuring units or measuring devices, it may not useful directly. So therefore you have to process the data into useful information. So we have to identify useful information from the given data, and then we have to do the analytics, and then you have to take the action or decision. Now see what happens in case of a mechanical example. First one, see, again time, with respect to time. Remember, whatever the data you are considering or you are collecting, that is with respect to time. So time is the universal uh, independent variable, and along with time only you have to take the data. So in the data collection, see the data collection here, vibration and then temperature, because it is a mechanical related thing, na? So based on temperature, if temperature increases, generally that vibration also increases. So at 5 time intervals, we recorded the data of both vibration as well as temperature. So this is what the data recorded from the sensors directly. Now see the processing. The individual vibrations may not helpful to take the decision. So therefore what we did the moving average. So moving average is the parameter. So moving average is the parameter, and we are identifying the moving average of the data to take the decisions. So for T1, T2, moving average is not required. So from T3 onwards, if you take the first 3 samples, T1, T2, T3. So see the moving average of the 3 samples. Look at the moving average for T3 and for T3 time and T4 and then T5. Like that, you have to see the 3 consecutive informations or 5 consecutive informations like that. Because why it is required? So transients or some sort of disturbances also may give such type of violations. So therefore we need the moving average information or a information over a period. Don't take the decisions based on 1 or 2 answers. Well, let me give one example. So let us see, during Viva, if external examiner will ask only one question, accidentally you are a person maybe having 10 backlogs, but accidentally you know the answer for that one question. If he allotted a maximum of 100 out of 100 based on that one question, what happens? Is the assessment is correct or not? Is the assessment is correct or not? External examiner want to allocate the marks based on Viva, right? Instead of asking 4 to 5 questions or 10 questions, if we ask only one question and based on that particular question, if we allocate the marks, is that assessment is correct or not? Yes or no? Huh? No or yes? No, perfect no. Let us say the answer have only two optional, multiple options, yes or no. Based on that, he will decide. Na? So he asked one typical question. Merit, for a merit student, he unable to answer that question and he got 0 marks. Yes or no? He said yes, but the answer is no. He intentionally put that value of marks is 0. Another student, again, answer question is same, yes or no. He opted yes. Luckily, that answer is correct. He assigned 100 marks. Then tell me whether the assessment is correct or not. Giving marks is correct or not. No. So that is what the incident, only one action. So that is the reason why in majority cases what we will do, instead of taking only one observation, don't take the one observation and decide. Based on one observation, don't decide. Na? So particular person in a class, in a particular class, maybe ఏదో చిన్నగా నవ్వాడు అనుకోండి. So based on that, can I decide his behavior? Is it the way? They are the simple examples. So better to observe over a period. If continuously absent, okay, you can take that particular student is irregular. If continuously getting low marks, then you can take his performance is low. So like, so that is the reason. Na? So the second step in the processing, we are taking moving average or a average of average over a period like that. So that is what the processing here. So and then analysis. If you see the analysis. In normal vibrations, that vibration should be 2 mm per second. Whenever faults occurs in the system, that vibration will be more. So it is greater than 3 mm per second. So based on that cumulative information, we can tell. So only the information at C. You have to see the gradual increase in the value as well as you have to see the individual observations. You have to see whether this is a temporary, a transient or permanent. You have to see all these things into the consideration before taking the decision. So that is the one example in mechanical, and now in similarly you can take the computer science examples also. No, so everywhere we will browse so many sites. Na? If you open Instagram or maybe Facebook, based on videos watched by you, new videos will be recommended to you, isn't it? Yes or no? If I show 2 of my YouTube channels, in one channel, uh, all the education content will be displayed because that is the channel related to the education. The another channel, my personal channel, where frequently I used to watch old movies and comedy movies, the comedy clips and old movies, black and white movies. So therefore, in the entire list, I have only such type of recommendations. So that is only based on application of data. Na? So how your previous data is nothing but your previous data information. How you used to search the different type of videos. Based on that, based on your past history, new recommendations will appear only based on the AI. So this is what the one example related to that. Same again, you have to take. So there in this the see collecting data is same in all cases, but processing data differ from case to case. So from application to application. In first application, we have to calculate the power. In the second application, we have to calculate the moving sum. In the third application, we have to find out the engagement score. So like that. Now, let us say, in all these cases, we can apply classifiers at the step 3. After step 3, you can apply intelligent classifiers to make the decisions. And the fourth one, which is related to this particular topic, water quality, something like. See, again collecting data, we have sensors to identify the pH value and total dissolved solids, alage turbidity. Like that we have n number of parameters. Parameters you can increase. You can increase the number of sensors and you can record more number of observations and more number of input parameters. Now see, after identifying, after collecting the data, the second one is processing. Here the processing is not cumulative matrices or the average matrices or something else from the measurements, collected measurements, calculated with the help of sensor data, na? Otherwise collected data. It is something different from the earlier example. See the example. Whatever the observations we are recording, we have to compare with respect to standard limits. See the example. We measured the pH value. Generally, the pH value should be within the, should be 7. Neutral case, the pH value is 7, right? If it is acid, the pH value less than 7. If it is a base, greater than 7. That's we know, na. So, but acceptable range is 6.5 to 8.5. So that is the acceptable limit. If the water quality is good, acceptable, then that limit should be 6.5 to 8.5. Now the second one is TDS, should be less than 500 mg per liter, and then turbidity. So like that, if you have n parameters, for n parameters you have n specific limits, and based on the limits you have to understand the data and you have to analyze the data whether it is acceptable or not. That is the analysis. We collected the data and then we processed the data, nothing but comparing the data with the help of specific limits. So after that we analyze the data whether the value is acceptable or not. So if you see the sample 1 where pH is 7.2, which is in between the 6.5 to 8.5, TDS is less than 500 mg per liter and turbidity also less than 5. Am I correct or not? So everything is okay, so therefore the sample is good. If you see the sample 3 where the TDS value exceeds 500, and if you see the sample 5, it is very poor. Now if you recall the example I made in the first first couple of slides, recording temperature and comparing the temperature, if the temperature is hotter than the previous week or not, na? So same way we are converting the numericals into linguistic variables, right? Linguistic variables. Now see how the intelligence will come into the picture. If you ask a device, it will tell you the value, numerical value in a fixed format, maybe 10, 20 like that. If I ask a human being, how you will explain? High, very high, low, very low, poor, good. So this is what the terminology or the variables used by the human beings. If you see one of the intelligent classifier, fuzzy logic, where everything will be converted into numericals to linguistic variables. Such type of examples you come to know in future also. So this is what the analytics, and based on that we can decide whether the water quality of a specific sample is accepted or not. The decision. Fourth one. So like that. So if you have data, you can apply, you can process the data. You have to do some analytics on the data, and you have to take the decision. The first 3 steps are common. Take the data, collect the data from field visits, from laboratories, from available sources. You can collect the data, and then you have to process the data. Means whatever the raw data we have, which should be converted into useful information. So that is the second step. The third step is do something on the data, do some analysis on the data, whether the data is acceptable or not, whether the ranges are is okay or not. whether we need to compute the any average indexes or not, or we need to compute any errors or not. So that's what the analysis, and what are the reasons for such type of changes. If something is happened, what is the reason? Do you have one reason, a specific reason, or multiple reasons? So like that, you have to prepare the entire tables, and then you can take the decisions. So this is what we have in the data analytics. Clear? Collecting data from the sensors. This is a direct step. After that, you have to process the data. Depending on your application, the processing will change, and then you have to analyze the data. You have to analyze the data. So based on the application also, this analysis will depend. Once if you collect the data, analyze the data, and collect the data, process the data, and analyze the data. After that, you have to take the decision. Again, if you see, now the data part is over. So if you give this data after analysis, if you give this data to machine learning algorithm, then machine learning algorithm will be trained and then tested with the data, and then we can use it. But what are the additional mechanisms we have to add to this topic so that your uh, performance of that AI tools or performance of the machine learning algorithms will increase further. So in that, the second one is a feature engineering. This is something separate. So now we have data, and the data we are collected, we are processed, we are analyzed. Clear? It is clear? Yes or no? Now we have to get the, or we have to give this data to machine learning algorithms. That's what we discussed previously. Now see, again I will recall the diagram. First basic model diagram. Look at this, not this. Before this, we have a basic diagram of raw model, and then raw data, and then model, basic model. Now the raw data is not useful, so therefore what we did, keep it in mind that diagram, and the second diagram will be this one. Raw data is not useful directly, so therefore you have to clean the data, and then you have to do the analysis. 3 steps: collecting data, processing data, and then analyzing data, and then give it to machine learning algorithm, so that machine learning algorithm will give the decision. So the decision will be taken by taking care of the AI systems. So that is the steps we incorporated in the data analytics. Now what we did, instead of taking the raw data is processed, analyzed, and then given to the machine learning model. Now some more additional changes in that model. So that is what the feature engineering. So I will give you a very good example. Have you studied Fourier transform? Have you studied Fourier transform? A Fourier series in engineering mathematics? How many? How many? How many? Fourier transform or Fourier series? You are from ECE. So therefore required. Mechanical students? Fourier transform. Computer science students? No. Civil? No. It is compulsory. Okay. I will explain you, don't worry. Just turn this side. Just turn this side. Oh, only 5 minutes. See, I am observing the motion of a device. Let us take simple, just like a simple harmonic motion. You know this example, right? Physics example, basic example. So I want to draw the amplitude of the displacement with respect to the mean position. Initially, the amplitude at the displacement will be 0 and reaches to maximum value. Again 0 and reaches to another maximum value, and again 0. So one complete rotation. Am I clear? And I want to plot this physical, see this is what physical equipment. I want to draw this variation mathematically, means I have to record. So if I record this, I will get this graph. Are you got my point or not? Initially the value will be 0, attains maximum, again 0, attains minimum in the reverse direction, again 0. That is the reason why it is simple harmonic motion or the periodic in nature. Periodic motion, same repetition. Okay. Yes or no? No? Clear? Now, small disturbance is given when this pendulum is at this point. Small disturbance is given. Initially, when we provide provide some disturbance to this device, then it will do some oscillations there, small oscillations, right? So let us see. Here, here it will change like this. So that's why the amplitude changes like this. Clear or not? This is smooth, na? This is now if I record the data at different time intervals T1, T2, T3, and this is not possible, ideal cases. So for understanding purpose, I am giving. So T1, I measure the amplitude. T2, I measure the amplitude like this. So there also I have the amplitudes. The amplitudes are within this range only, na? Within minimum range, right? If I apply a large, large disturbance here, its amplitude increases so that I can identify based on the magnitude. Am I clear or not? If this amplitude increases, this displacement increases, I can find out the variation because the magnitude changes a lot. So only that recorded information is enough. Like your overload current. See overload value initially 0.9 amperes and then 1.6 and suddenly 2.5. So that variation in the magnitude, if you see the variation in the magnitude, that is enough to understand something is happened in the system. So in the similar way, here also magnitude varies drastically, we can understand. But here what is the difference here? Is the magnitude? Is the magnitude or not? Is the magnitude or not? Magnitude is in the limits only. You cannot observe the magnitude. Na? Now what is the difference here? Now it is a perfectly periodic in nature of some frequency f. But if you observe this cycle along with this fundamental f, we have some more additional f1, f2, f3 and so on. So this is what your Fourier analysis, Fourier series, representing a periodic signal as a sum of sinusoidals consisting of a fundamental harmonic, fundamental frequency 2 times, 3 times, 4 times and n times frequencies. Forget about it. Now, if you see the time based measurements, means time based magnitudes, T1 time magnitude is 1 ampere, T2 2 amperes, T3 3 amperes. If you see only time based information, you cannot take any decision directly, even though if the data is very good. The data is very good, you recorded every time data, but you cannot take the decisions. Why? The entire first cycle as well as the second cycle are in the same way. Only some additional noise is there, some additional disturbance is there in the second. If I calculate the frequency of this particular graph, it is one value. If I calculate the frequency of the second graph, it has multiple values. Now, instead of taking time data, you have to take what data it is. What is this data? For periodic signal, instead of taking time, along with the time, we have to take the frequency data. That is called the feature. It is very difficult to understand, sir. So tell me a very simple example, a basic example. He is my classifier. He is my classifier. They are my inputs. Initially provided input features as weight and heights using the sensors, weight sensor and height sensor. Height sensor is tape, weight sensor is paying machine. And later I will apply some disturbance, then రెండు పీకేలు అనుకోండి బాబాయ్ అంటారు కదా. సో దట్ ఈస్ వాట్ ద థర్డ్ సెన్సర్. సో immediately he will receive the new feature information, that is voice. So based on that he is able to classify the system. That is the thing. So that is what the feature. Now see the definition of feature. A feature is an individual measurable property or characteristics of the data that is used as an input to machine learning or AI model. That's it. For my classifier, weight is not useful, height is not useful, but voice is useful. So how to get a voice from the information of weight and height and additional things? So that additional feature will be useful for the machine learning algorithms. So that is one example where the time data is converted into frequency data, and once if you give such type of meaningful input information to, so if I provide height data, weight data, he is not able to classify the boy and girl. But if I provide same system, right, same system, but if I provide the voice data, immediately he classified the boy and girl with the accuracy of 100%. So what happens for if you give such type of feature? See, feature control, model performance. Automatically model performance or the accuracy will be increased with the help of features. So this is the additional thing, means directly data may not be useful. From the data you have to extract a few additional features. They are meaningful input variables that helps to identify the patterns of the data. Directly the time based data may not be helpful to understand the variation. So therefore if you convert that into a frequency data, where initially for first cycle only one period, one information, one frequency, but second cycle consisting noise. That noise is nothing but a disturbance with multiple very high frequency. So that frequency, additional term frequency information is helpful to identify the disturbance in the system. So like that we can do things. So the feature increases the performance, and then feature increases the features increases the efficiency of the model or the classification accuracy of the model if it is a classifier, and see reduces the noise, remove the noise and removes the irrelevant information. And see, if you have 10 inputs, but from 10 inputs if you are able to get one or two important features, then you can eliminate the remaining 8 inputs. So once the data size is reduced, automatically the training rate will be increased, right? So all these are the important merits of the feature engineering. So what are the steps here? Again, see the features, actually different type of features. For example, if you have time data, that is the time data. T1 I have value, T2 I have value, T3 I have value. So that is what the recorded data. From that, what type of statistical measures I can find out? Mean value I can find out, variance, standard deviations, all these statistical parameters I can find out from the direct time data. So time data may not helpful to identify the patterns, but if you identify the mean is increasing, so standard deviation is increasing. If you see the peak value changes. So all these are the observations we can made from the data, and then those observations or those features helpful to train the machine learning model in a better way. And such type of modified features, such type of features are increases the accuracy of the machine learning model. So this is what the direct from data you can measure all these things. If you have a table, from the table, or if you have a numerical data, from that numerical data you calculate the mean, you can calculate the mode, you can calculate the standard deviation, you can calculate the RMS value, etc., etc. I already mentioned the period. So one cycle. So similarly time, and additionally for each period frequency information, frequency components. If you have signal, so pictorial representation of time information is signal. If you have signal, you can find out the moving average. We already observed the moving average in mechanical example. For each time we have the vibration information. From that we calculated the moving average. So that is a one. And how many times zero crossings. So based on that, see, for example, see here see, in this time interval, one zero crossing. For example, here like this. So number of zero crossings increases, means something is happening in the system. Like that we will do so many things we can do. It is not a simple thing, and you cannot fix on a simple one parameter. Based on application, you can select n number of parameters. If someone designed a system only by taking the mean values of the recorded information, if you add standard deviation also, the performance will increase, because only mean will give you the average information of a certain period. If you take the standard deviation also, based on standard deviation you can understand whether the values are varying a lot or little variations. So based on that also we can decide. Na? So all these are the important things. So features from the data, these are the different type of features from the data. I mentioned Fourier transform. It is a time frequency transformation. So whatever the signal we have x of t, which is a time domain signal, which will be converted into frequency domain. Means if you have time domain, you cannot be able to extract the meaningful information from the time data. So therefore, you have to use the frequency information. That is what time frequency transformation. So like that we have fixed transformation techniques, and after that, for example, we have for a specific data, if you extract the features are 100 features. 100 features may not be useful. You have to reduce the features, because 100 features means the computation time will increase. Machine learning algorithm will take a lot of time to train the model or test the model. So therefore, you have to reduce the number of features. So feature reduction is also possible, because all the features may not be used. So that is, and then feature optimization. What type of features we can use? How optimally we can design features. So that is another thing. No, all these are all the research areas. If you identify one area, if you stick on one area, you can do miracles on that particular area. Data collection is common, data analysis is common. After taking the data, if you visualize the data in different ways, you come to know all this. But they are not required actually as a student. No? They are very advanced level. But simple thing. So understand the data, analyze the data, get some other additional information from the data. That's it. So that is how we will do with the feature extraction. Complete information. So I think majority are not familiar with Fourier transform and then different type of methods. So that's why I don't want to explain all these slides. Now see what happens to our previous system. Raw data, machine learning model. Next, raw data, cleaned one, processed, analyzed, machine learning model. Now what happens? After analysis, after finding the patterns, after finding the anomalies, you have to extract the features from that data, useful features, and you have to reduce the features, and you have to select the features. Maybe 100 features you can extract from the data, but from the 100 features, you can use 2 or 3 features optimally to get the maximum accuracy. So that is what feature selection. So you can select the features, and then those features you can apply for the machine learning algorithm. Now what happens I will explain. So initially raw data of size, let us consider 1000 samples. For each observation 1000 recorded values, 1000 sensor values, and after cleaning maybe uh, eliminated or 10 values, means it becomes 990. After analyzing, they are increased to, or maybe they are decreased to 100. So 1000 input information initially we are providing, but we may not get the acceptable accuracy. So after removing the unnecessary things, after doing the analysis, after observing the patterns, we got only 100 features, the 100 new data inputs. So those 100 may, if you provide to the machine learning model, initially if you give direct data, the accuracy is 50%. After reducing the 100,000 to 100 meaningful information, your accuracy may increase to, let us say, 70%. Now with the 70, you are extracting 700 features. Remember, 70 inputs become 700, again increases size, and among 700 may not use, all the 700 may not be useful, reduce it to 7, and that 7 features, useful features after feature extraction, will enhance the model performance to up to 90, like that. Initially if you give the raw data, performance is 50%. If you use the analysis data analytics, performance becomes 70%. After data analytics, apply the feature engineering, get the more features, identify the select optimal features, give the less number of optimal features to the machine learning model, then accuracy becomes 90. So this is how, because ultimately what is our objective? What is our objective? Maximum accuracy, minimum loss. So either maximization or minimization. You are writing exam. What is your objective? Getting 4 marks. You are attending for interview. What is your objective? To see the face of HR or TR, or to get the placement with the maximum package. Isn't it? So that is the ultimate objective. So here the objective also getting a maximum accuracy for the machine learning algorithm. If you give direct input 50%, processed input 75%, processed input and then features and then optimal features 90%. So this is what we have to do. This is basic model now. Initially raw data to machine learning model becomes raw data, cleaning, analysis, feature extraction, reduction, and then feature selection, and then machine learning model. So the process of collecting, cleaning, transforming, and analyzing data integrated with feature engineering. So this is what our modified system machine learning. That but now data is over, data analysis is over. From data analysis, taking the useful features is over. Now we have to take the, we have to give that useful feature or useful data or modified data or maybe structured data to a machine learning model. Now what is machine learning? What is machine learning? Or what is artificial intelligence? Okay. Before going to explain this, I will give a very simple example. Again, here is my system only. Again, my inputs, where just my inputs, my 2 inputs. One is there. Now let us consider my system have 2 inputs. Input features are voice. What is the efficiency? 100%. Very good. Now this is my system without ears. Now tell me the efficiency. Is those features are useful or not? No. Right? Now what I have to do for this system? If I use different type of features, the efficiency will be 0. So therefore I have to do some architectural changes. Architecture changes. Architecture means this system does not have ears. So therefore I have to add architecture modifications in the system, right? So that's you can do in the machine learning, because whatever the machine learning algorithms, we have so many algorithms already existing in nature. Now if you do something, you have to take the original algorithm, apply input, apply data to original algorithm, get the results. Maybe the results may be not impressive, So in such case, if you cannot do anything with the data, then do changes in the architecture of the algorithm. Okay, so these are the possibilities actually. Huh. They are one the above sentence is in the Mahabharata, and the below sentences are from Bible. You know, machine learning, where it originates. I started na, so data analytics in the second class or first class tables, like that machine learning. No. So see that actually Kitopakyana, the conversation between Vyasa and then a small creature. You know that conversation? Huh. తెలుగులో చెప్తాను. వ్యాసుడు కౌరు పెట్టాడు, వ్యాసుడికి మహారాజు కౌరు పెట్టాడంట. సో వేగంగా వెళ్తున్నాడు, మహారాజు దగ్గరికి వెళ్తున్నాడు. ఈ లోపు ఒక చిన్న కీటకం, చిన్న పురుగు రోడ్డు దాటి అవతలకి వెళ్ళిపోతుందండి పరుగు పరుగున. మనోడు కూడా పరుగు పరుగున మరి మహారాజు పిలిచాడని పరుగు పరుగున వెళ్తున్నాడు. ఈ వెళ్తా ఉంటే ఈ కీటకాన్ని చూసి, ఈ నేనంటే పని ఉంది కాబట్టి నేను వెళ్తాను, దీనికి ఏం పని ఎంత ఫాస్ట్‌గా వెళ్ళిపోతుందని దానికి మాటలు ఇచ్చి అడిగాడంట. నాకు పనుంది. రా రాజుగారు పిలిచారు కాబట్టి నేను వెళ్తున్నాను. నీకేంటి అంత కంగారు? అలా వెళ్ళిపోతున్నావు, అంత ఫాస్ట్‌గా వెళ్ళిపోతున్నావు ఈ రోడ్డెంబట అంటే, సో కీటకం చెప్పిందేంటంటే, ఈ రాజుని కలవడానికి వేరే రాజు వస్తున్నాడు. ఆ వచ్చేవాడు సింగిల్‌గా వస్తే పర్లేదు. ఆడెనకాల ఒక 1000 ఏనుగులు, ఇంకో 1000 గుర్రాలు, ఒక 10,000 మంది భటులతో డటాటగా వస్తున్నాడు. నేను త్వరగా ఈ రోడ్డు దాటి నా గమ్యానికి వెళ్ళకపోతే ఆళ్ళు ఎవరో ఒకళ్ళు నన్ను తొక్కేస్తారు. నేను పచ్చడైపోతాను. అందుకని నేను చాలా ఫాస్ట్‌గా వెళ్ళిపోతున్నానంటే, ఏంటి రీజన్ అంటే, నీకెలా తెలుసని అడిగాడండి. పాస్టర్ నీకెలా తెలుసని అడిగితే, వాళ్ళు వస్తున్న శబ్దం ఉంటుంది కదా! వాళ్ళు నడుచుకుంటూ వస్తున్న శబ్దం వైబ్రేషన్. ఆ వైబ్రేషన్ నాకు తెలుస్తుంది. సో, అంటే ఆ వైబ్రేషన్ నాకు అర్థమవుతుంది. అందుకని నేను అబ్జర్వ్ చేసి నాకు అర్థమైంది కాబట్టి నేను వెళ్తున్నాను. సో, దిస్ ఈస్ వాట్ ద స్మాల్ కన్వర్జేషన్. యాక్చువల్లీ ఐ వాంట్ టు కీప్ వన్ వీడియో హియర్. గరికపాటి గారి వీడియో ఒకటి పెడదాం అనుకున్నాను. బట్ అనేబుల్ టు ట్రాక్ దట్ వీడియో ఇన్ ద నెట్. దట్ ఈస్ ద వన్ రీజన్. నో, దట్ ఈస్ వన్ రీజన్. Remember, a small creature identified the sound waves, the vibrations in the earth from a long distance. Na? So that is the one thing. The second thing, if you see the Bible, actually in Proverbs, దేవుడు ఏం చేస్తాడంటే చీమల దగ్గరికి వెళ్ళమంటాడు. వై? ఎందుకంటే, సో హౌ దే విల్ సెర్చ్ ద ఫుడ్. లుక్ ఎట్ ద వే హౌ దే సెర్చ్ ద ఫుడ్. బికాజ్ వర్షాకాలంలో వర్షాలు వచ్చేస్తే ఎక్కడికి వెళ్ళడానికి ఉండదు. అందుకని ఏం చేస్తాయి? సమ్మర్‌లోనే వెతుక్కుని దాచుకుంటాయి, స్టోర్ చేసుకుంటాయి. ఆ వెతికే విధానం ఎప్పుడైనా చూసారా? ఎప్పుడైనా చీమలు వెళ్ళడం చూసారా? యూనిక్ వే. ఇక్కడ నుంచి మిమ్మల్ని కిందకెళ్ళమంటే 80 మంది 80 దారుల్లో వెళ్తారు. అదే చీమలు ఏం చేస్తాయి? మీ చుట్టూ 10 మంది టీచర్స్ ఉన్నా మీరు వెళ్ళరు. బట్ అటు చుట్టూ టీచర్స్ ఉంటారా? రాజులుంటారా? కాపలాకి ఎవరైనా ఉంటారా? బట్ దే విల్ ఫాలో యూనిక్ వే. You are thinking that it is in a spiritual class? No. Now what is the reason for that? The communication also. They will communicate to each other while searching the food also. Look at the way how they search the food. So they are a few examples from our history. I will tell you a few more examples. Do you know bat? Bat. డబ్బులు ఐస్ ఉండవు. నేను ఇందాకే చెప్పాను సర్వేంద్రియానం అందుకు అయ్యే ఉండవు. దెన్ హౌ ఇట్ విల్ ఐడెంటిఫై ద ఫుడ్? Based on sound signal కాదు, frequencies generated from the obstacles. It will generate a sound signal, and whenever some obstacle is there, that signal will hit that obstacle and reflect back with the other frequency, and that frequency received by the bat will identify the way in which way the food is there. Isn't it? So the availability of food, right? So like that, if you identify any creature in nature, they have their own learning algorithms, intelligent algorithms. Mimic such type of intelligence of different animals to a system becomes artificial intelligence or machine learning. That's it. That is the thing. Sir, అలా ఎలా నేర్చేసుకుంటాం సార్ అంటారేమో. I will give you the example. Don't worry. That is the example. That's how we will learn. చిన్నప్పుడు ఏం చేస్తారు? మళ్ళీ పక్కన కూర్చోబెట్టుకుని ఏం చేస్తారు? అమ్మ అమ్మ అనరా, అత్త అత్త అనరా. Isn't it? మేక, కుక్క, కోతి. That is how the child will be trained from the expert. Isn't it? Yes or no? People will like, is it a fact or not? We are trained like that only. Nah. So that is the training. Now see the thing actually. Initially, by showing the frog, it is a frog. After that, by showing the lion, it is a lion. That is what training. Now you will show the different image. What is that? Bird. అలాగే నేర్చుకున్నారా మాటలు? అలాగే మీ మెకానిజం ఉందా? అలా మీరు నేర్చుకోలేదు అనుకోండి, మిమ్మల్ని ఏమంటారు? వీడు తెలివి తక్కువడు, వీడికి ఎన్ని చెప్పినా నేర్చుకోడు, రైట్? తెలివి తక్కువతనం అంటే ఏంటి? Without having intelligence, that's it. Wow. This is what the mechanical. Now see, frog, lion, bird. This is what the data, and the system is trained by the knowledge expert, and then tested on a new data. So data we have to take, and learning nothing but training, and then execution, asking, nothing but testing. So machine learning models need data as input, and then need some set of rules or set of expert to train the model, and then we can test the model on a new data or the same data. It is always better to test on the new data. Now what are the different type of models? So from first slide onwards, if you see that machine learning model block, so many algorithms are presented. So linear, non-linear regressions, artificial neural networks, fuzzy, KNN, DTs, support vector machine, extreme learning machine, all they are called the machine learning algorithms, different machine learning algorithms. No, not having a perfect mathematical equation. If you give data, input data and output data, the model will be trained and then tested. That model can take 80% or 90% of the data for the training, and remaining 10% we can test, or 20% we can test. And for every model, we have specific parameters. We have specific parameters. So linear model is different and non-linear model is different. For every non-linear model, again for every machine learning model, the parameters will be different. Different type of parameters we have, and learning mechanism is also different. So some models may useful for some patterns of data, and some algorithms may useful for other data. Na? And evaluation. Generally, if you see the classification, then you can use the accuracy, precision, recall, F1 rate, such type of parameters. And finally, after training and testing, you have to see whether the algorithm is good or not. Only based on performance. Student is there. After test, we have to see the result. Based on result, nothing but number of marks obtained by the students. Based on that only, I can conclude whether the system is good or not. So similarly, here also, based on the some evaluation parameters like accuracy, precision, recall. So they are for classification algorithms. If it is a prediction algorithms, so you have to use the errors, mean absolute percentage error, root mean square error, mean square error. Such type of parameters you have to take to evaluate the performance of the machine learning algorithms. They are the main steps in the machine learning algorithm: method and the parameters involving the method, and process and evaluation. Now see, you have how many persons here? 80, around 80. Now let us continue. So I explained linear regression method. Okay, time pyramids. If I explain linear regression method, now I will give the same data to you, right? You can adopt different kinds of learning mechanisms or optimization algorithms to identify the coefficients. Means you can develop 80 different models, 80 different models. Like that, for every method we have n number of variants. If you do something, if you change some architecture in the method, and if you test, if you train and test on a specific data, if you get a good results, then definitely that will be acceptable. So many you can do it. This is what the entire thing, na? Same information. Let us see. Actually, in this slide, actually what I presented, different type of machine learning models and how you can do the uh, how you can uh, find the models, how you can test the models, what are the types of real time examples. So all I presented, they are not required. So let us take one application. Again, I don't want to give a complex example as application. I will give very simple example as application, right? Do it. So underline, mathematics will give you the exact answers, whereas machine learning algorithms will give you the approximate answers. Is it clear? Now note down one simple problem. Find 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 a straight line. Find 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 a straight line passing through 2 points 1 comma 1, 3 comma 4. Find a straight line, equation of straight line passing through 2 points 1 comma 1 and 3 comma 4. Do it. Problem related to intermediate mathematics, not intermediate. ఇప్పుడు వచ్చింది అలాంటిది 8th class, 9th class. Okay, 9th class. Do it. If I have 2 points x1 x2 y1 y2, can I find out the equation passing through 2 points, straight line passing through 2 points, and do it. Do it. What is the equation? Do it. Again, see where I started. A system describing by a linear equation y is equal to mx or y is equal to mx plus c. Something different, small c. So that c is nothing but intercept. So same. I will come to that point. So I started at that point. I will end my session at that point only. Now find out a straight line equation passing through points 1 comma 1 and then 3 comma 4. Not only for this subject, any subject, try to understand the basics, try to take the flavor. Na? If you by heart the big equations, what is the use? Tell me, what is the equation? Don't ask ChatGPT. You're asking ChatGPT. Now see, you have to use the AI or maybe any other tools to enhance your skill, not to kill your skill. If you're depending on such type of sites, నా సినిమా మల్లీశ్వర్ సినిమాలో చూసారా, కాలు ఎత్తడానికి ఒకళ్ళు చేయి ఎత్తడానికి ఒకళ్ళు పిలుస్తాడు. రేపొద్దున మీరు ప్రతిదానికి చాట్ జీపీటీ ఓపెన్ చేసేసి కొట్టేశారు అనుకోండి, రేపొద్దున 2+2 ఎంత అంటే మళ్ళీ చాట్ జీపీటీ ఓపెన్ చేసి 2+2 ఎంత అని అడుగుతారు. ఆ సిచ్యువేషన్కి వెళ్ళిపోతుంది. డోంట్ use the AI based tools to improve your skills, to enhance your skills, not to kill your skills. Na? What is the equation? Huh? Tell me, what is the equation? Y minus y1. Y1. Uh, First find out the slope 3/2. Y2 minus y1 is 3. X2 minus x1 is 2. 3/2. Y minus 1 is equal to 3/2 into x minus x. Y minus 1 is equal to 3x minus 2. 2. So 3x plus 2y plus 2 minus 2. No. 3 it is. Minus 3 minus 1 equal to 0. See, y is equal to minus 3/2x plus 1/2. Am I correct or not? Y is equal to minus 3/2x plus 1/2. Yes or no? Substitute 1 here. Minus 3/2 plus minus 2/2. 1 అవుతుందా? I think 3/2x minus 1/2. అంతేనా? 3 3 is 9. 9 minus 1 సరిపోయింది. రైట్, కరెక్ట్. అంతేగా? Y equal to 3/2x minus 1/2. So that is the equation passing through two points. Very good. Means what is the value of x? If I give x, then system is 3/2x minus 1/2. Therefore y is 1. If I give x is 3, y is 4. Right? Correct or not? Same type of equations. అరే బాబు, ఎక్కడ మొదలెట్టిన అక్కడికి వచ్చాను చూడండి. If my x is 1, y is 1. If my x is 3, y is 4. Where equation of system equation is y equal to 3/2x minus 1/2. Right? Very good. They're all good. Now, so this is okay. So this is what I mentioned, the mathematical model. This is what I mentioned. If 3, x is 1, y is 1. If x is 3, y is 4. This is what AI model, where I don't have system, only I have input, output. Yes or no? Right. Now, find out a straight line which is passing through. Now, write the question. Write the question. Write the question. Find out a straight line. Find out a straight line which is passing through 1 comma 1, 1 comma 1, 1 comma 1, 2 comma 2, 3 comma 4. Now do it. Now find out a straight line which is passing through 1 comma 1, 2 comma 2, 3 comma 4. Now do it. So mathematical model I know. From that AI model I can develop. Now can you identify the mathematical model for this? Do it. Huh? If you draw the line which is passing through 1 comma 1 comma 2 comma 2, which is y is equal to x, which does not on, sorry 3 comma 4 is not on that particular line. If you take a line passing through 1 comma 1 2 comma 2 points, then 3 comma 4 will be not on that line. If you take a line which is passing through 1 comma 1 3 comma 4, 2 comma 2 will be not on the line. If you take a line passing through 2 comma 2 3 comma 4, then 1 comma 1 is not on that line. Now tell me what is the value, what is the line passing through those three lines? Huh? Straight line, you cannot find out straight line. You have to find out straight line. Ultimately, you have to find out the straight line. There you will get an approximated value. So that is the reason why I mentioned always AI system will give you not exact answer, approximate answer. Now see, let us see. For example, you conducted an experiment, you got these three values. How you will draw? You will draw a line which touches, which is nearer to all these 3 points, right? Am I correct or not? Means the error between the line and point will be very less. So the sum of errors between the line and points will be minimum. You have to take a optimal line which is close to all these 3 points, such a way that the errors between the line to points will be, sum of errors between the line to points will be, generally error positive negative ఉంటుంది కాబట్టి sum of squares of errors, so that positive negative కూడా cancel అవ్వదు. Sum of squares of errors should be less than, should be minimum. So that is the concept of minimization of error. If you see the previous slide where the performance attributes, root mean square error, mean square error, root mean square error, percentage also always positive, mean absolute percentage, absolute means always positive. So such type of parameters. So if you see the simple concept na, how you can get that so this is what, this is what one machine learning technique called the linear regression. Now if you open your mobile phones, if you type some example, what is our present title? Water quality. And now just in Google, just Google it, water quality prediction using linear regression. Just Google it. Open your mobile phones and just no mobile. Just open your mobile phones and just Google it. Water quality analysis using linear regression. That's what the linear regression. Getting a linear lines for set of points. Have you got any results? You will get so many AI applications, so many AI related papers. Which in the, if you see, go to the results, not AI content. Go to the results. See, so many papers. The below, you have so many papers, research papers. Application of linear regression to water quality. Now see what you have to do. Already, if you know how to take the data, Nana, at the end, if you know how to take the data, collect the data, process the data, right? If it is possible, apply the feature extraction or feature engineering. Otherwise, take direct data, no issue. And for that data, if you apply a linear regression, that is nothing but a linear equation passing through your entire data. Not exactly, approximately touching majority of the points, fitting to majority of points. If you identify that equation, that's itself an application. You can show it in any project. It is linear regression. Replace the linear regression with non-linear regression. Replace to ANN, replace to SVM. Like that, you can replace any method. Clear? So we started from the very fundamental to again at that fundamental. Same, but we are not going to get exact answer, because today, if you see the stock market prediction, who can get exact? If you know tomorrow specific particular stock value increased by 2 rupees, everybody will invest in that particular stock, isn't it? So we don't have such type of mathematical expert. Everything will be approximated answers. We may get solutions, we may get correct solutions sometimes, and we may not get correct solutions. That is right. So that is what data analytics for machine learning in a simple way. If you have any doubts, you can ask me. And better to take my contact details as well as my mail ID. You may contact me at any time for any application, electrical, mechanical, civil, whatever it may be. Generally, uh, so I will be always in my cabin only, except classwork. Only for classwork I will go to class. Otherwise, always in my cabin. I will be at 201 D201 in electrical department. So if you want to do any project related to the machine learning, if you have any clarities, or if you want to write any paper, any research paper, or if you want to do means any product related to the machine learning, data analytics, and related applications, sensor, IoT based applications, you may come to me. Okay. If you have any doubts, you may ask. Any? You can ask. I believe that the positive feedback is always and increases the instability in the system. Is not good for system. Negative feedback is always good. అలానే అంతా నెగిటివ్ వచ్చేది కదా. So if you get 100% positive feedback or 100% positive feedback, then something is biased. Some biasing is there in the system. I know this feedback mechanism. Literally, if you want to learn anything, just explore the concept. Try to understand the basics and explore the concepts. బండ్లు పుస్తకాలు చదివేస్తే కానీ ఉపయోగం ఉండదు. ఇఫ్ యూ ఎక్స్ప్లోర్ ద థింగ్స్, దే ఆర్ వెరీ ఈజీ, వెరీ ఈజీ. మనకు పుస్తకాలు ఉన్నాయి, తెగ చదివేస్తున్నాం. ఆ ముందోళ్ళు వాళ్ళకి ఏదో లిమిటెడ్ సోర్సెస్ ఉన్నాయి, ఓకే. ఆ ముందోళ్ళు ఎవరో ఎప్పుడో ఎక్కడో అక్కడని ఎక్కడో ఒకటి మొదలెట్టారు కదా, మనం కూడా అలాగే మొదలెట్టాం. యూనో. సో థ్యాంక్ యూ ఫర్ your patience to listen all the topics. If you have any doubts, you can ask. నా నెంబర్ కావాలితే వంశీ సార్ ఇస్తారు, లేదు అదర్వైజ్ యూ కెన్ టేక్, నో ఇష్యూ. నెంబర్ 9705981727. 9705981727. రైట్. 9970598117. So that is the mobile number. I'm an introvert, so better to text, don't call. No. Save that number. Whenever you need something, some help, feel free to contact. No issue. Mail ID? That is Gmail ID. Actually, take institutional mail ID. Gmail ID generally I don't want to prefer. It's only for personal reasons. I have everything too, right? So two IDs, two Facebook IDs. One is a personal or professional ID, another one is personal ID. Hmm? Huh? Huh? పేరు తెలీదా? సార్ వంశీ సార్ వచ్చేస్తారు. వంశీ సార్ సెషన్ అయిపోయి మీకు ఎక్కడైనా కాంప్లెక్స్ కనిపించిందా సార్? కాంప్లెక్స్ కనిపించిందా టాపిక్? అసలు అనిపించలేదు. నో, డేటా అనలిటిక్స్ వన్ బ్రాంచ్, AI one branch, machine learning one branch. Don't think they're very easy. ఇంకో సెషన్ ఉందా రేపు? మీరు సెకండ్ ఇయర్ లో ఉన్నారు కదా ఇప్పుడు అందరూ? థర్డ్ ఇయరా? సెకండ్ ఇయరా? సెకండ్ ఇయర్, థర్డ్ ఇయర్. బెటర్ టు డూ